Now we will solve problems on exponents. There are two different types. One is with different base and one more is with same base. Now, first type of problem is to find the whole number that is equal to this particular number. It is 4 divided by 5 to the power minus 2. It looks complicated, but let's split it out and make it look simple. Since this is in denominator, we can multiply that. So 4 multiplied by 1 divided by 5 to the power minus 2. This is the same thing. You have just written it separately. Now we have a negative power. Now there is the rule of exponents. So if you have any negative power, say let's take minus 2. If you take this thing to the denominator, then it changes its sign of the power. It becomes positive from negative. But if this was positive in the first place, then this would have been negative. Now, what if it's like this in the denominator, x to the power minus 2? It's fine. Take it to the numerator, it's going to be positive power. So same thing we are going to do over here for 5. Instead of writing it in denominator, we write it in numerator and the power changes to positive 2. Now it looks pretty simple, isn't it? 5 to the power 2 is 25 and multiply 25 times 4. It will become 100. 25 tables, 4 times is 100. So that is your answer. This is the whole number. Now, let's solve another complicated problem. Now, these can be solved in different ways. Whichever is easy for you, just opt for it. Now, over here, you have many digits. So you can see 2 to the power 5, 4, nothing. That means it's 4 to the power 1, 4 to the power 3, 2 to the power minus 1. So generally in textbooks, what they do is they take everything from the denominator and bring it up and then simplify, because they just do this. So 2 to the power 5, 4 remains. Now whatever is in the denominator comes up and the sign changes. From minus 1 it becomes positive 1, and from positive 3, 4 to the power 3 becomes 4 to the power minus 3. Why? Because whenever you have same base, you can just add the powers, right? When you're multiplying different exponents, when the bases are same, you just add the powers. Or you can do it directly if it's divided by each other. If they are multiplied, then you add the power. If it's divided, you subtract the powers. That means it's going to be 2, 5 minus of minus 1. This is what it would look like. Over here now, since we brought it up already, it's going to be 2 to the power 5 plus 1, 4, 1 minus 3. Let us see otherwise how it would look. 5 minus of minus 1 and 4, the power is 1 minus 3. The answer will be same. 2 to the power 5 minus of minus becomes plus, so it will be 2 to the power 6 into 4 negative 2. 4 to the power negative 2. So the same answers are either ways. Then what do we do next? Simple. We need to simplify them. So 2 to the power 6, you can just keep on multiplying 2, 4, 8 to 16, 32, 64. So that is, you just keep on multiplying the answers with 2. So this will be 64. Now what about this? It's hard to do negative powers, so we just take it to the denominator. So what I mean is, just take this down to the denominator. It becomes positive power now. Now split them. 2 to the power 6 is 64. What about 4 squared? 16. 64 divided by 16. Here we go. The answer is 4. 16 4 times is 64. This is how we can solve this. Now this method can be used any way to solve any type of problems. So now for the different bases, you need to do this method. Now let's see with the same base, solving exponents with the same base. What's the difference? Here you can apply the same things what I just now told you in the previous two problems, and you can solve these. Over here you can Okay, this is by rearranging and all this, you will get this answer, right? But I will tell you another easy method. Whenever you have a same base, you can opt for this method, it's up to you. But look over here, there is a similarity. All the bases are 10, 10, 10. So how can you simplify this? Instead of going through all this hassle, just look into the exponents. Look at all the exponents over here. X, since they are in the numerator itself, just add the 4 equals to 15 and just simplify this. X value will be 15 minus 4, that is 11. You can directly get the answer. So don't go to do the long method when the bases are same. Just simplify directly. How about we see another problem over here? Don't worry about these all these weird looking thing. 12 minus 6. No, it's very easy, but just remember when it's denominator over here, it will be negative. Over here, you add the bases when they are in the same numerator. But if it's a numerator and denominator, you need to change the sign. You need to subtract. This will become minus. That's the only thing. So what do you do? It's 12 minus x. This goes up, so it's minus x again and equals 10. That's it. And then you need to simplify this, minus 2x over here, and then you have take this to the other side and bring 10 to the other side. It becomes minus 10 and positive 2x. 12 minus 10 is 2 and answer is x equals 1. So this is how you can easily solve it with same bases, but this doesn't work when there are different bases. Only when they are all the same bases like 5 5 5 of 10 10 10, you can use this. If it is two different digits, say 2 4 and 5, then no, you need to use the method which was taught at the beginning of the video. So this is how you solve exponents with different bases or the same bases.